How come
Okay,
you
thank
can't
you
hear
all for
us?
joining us. I have to apologize straight out of the gates for getting the time in a confusing manner in the invite. It said to 10 a.m. Pacific Standard Time, but obviously the clocks have changed in most countries, and it's actually now obviously 10 a.m. Pacific Daylight Time. So we'll have to try and do better on that, or I'll have to try and do better on that going forward. But thank you guys for joining anyway. Of course, we always record this meeting, so people could always come back and watch later on. So that's going to be quite exciting. Now I'm quite excited about today, particularly because we've got no less than kind of 2 community demos, and we know that people really enjoy those kind of demos. So I'm really looking for us being able to share that information with you. This is also the first time this year that we're going to combine both Argo Events and Argo Workflows into a single community meeting. Now, anybody who knows about Argo Workflows probably knows about Argo Events already. Argo Events is essentially a way to have events come into your cluster and trigger things within your cluster. And Vaibhav is going to talk about that shortly and give us kind of a really interesting demo showing you how you can stitch together both Argo Workflows and Argo Events. We're also going to have a demo from Marek from RedHat of Python DSL. Now, we know that a number of people want to use Python for running their workflows on Argo. It's obviously a lot easier to use than the YAML syntax, so he's going to do a bit of a demo on that later on. And hopefully we're going to close out with the survey results of the workflow survey we did about a month and a half ago, and probably hopefully you guys get to see some insights, and then we'll share around those slides later on if you would like to find it interesting. If you have any questions during this, then please just feel free to jump in and just ask them, or you can of course ask your questions in the chat room, and we'll hopefully read them out for the recording, and you can get answers to your questions. If you've got any detailed ones, obviously we can take those guys offline afterwards as well. Now, I think Marek was meant to do the first demo. Marek, are you online at the moment?
Yes, I am. Am I audible?
My sound might be broken. Okay, I don't think he's joined it. Vaibhav, are you ready to go now?
Sure. Hey, Alex, I think Marek is on Marek is on the line.
Yeah, my sound's not working, so that's why I can't hear what you're saying.
Mm-hmm. Well, let's try now. No?
I can hear you, Mark.
You can hear me?
Yes. Yes,
we can.
Oh, all right. Okay. Then I can present if you want me to go first.
Yeah, please.
Okay. Let me share the screen. All right. Just to check, can you see the slides?
Yes.
Perfect. Okay. So hello, everyone. This is Marek, software engineer at RedHat. And recently we've started to work on Python SDL for Python DSL for Argo Workflows. Now, let me first explain what is a DSL, because I get that question a lot. So DSL is basically an object-oriented way to define Argo workflows in Python. In general, DSL is a domain-specific language. It should provide some sort of an easy-to-use and user-friendly abstraction over another definition. That another definition, in our case, would be the YAML specification of Argo workflows. Here you can see what it can look like. On the left side, you have the Argo YAML file taken from the examples of the Hello World workflow. And on the right side, you can see the actual definition of that workflow as a class in Python. I'll explain a little bit more later on. This is sort of just to get you excited about it. So why is it useful? Why do we want to actually have something like that in Python? Well, first of all, that would be the integration with the Python SDK. It integrates seamlessly with the Python SDK, which is basically a client generated from the Open API specification. You can just define the workflow as I showed you before and submit it directly. That direct definition allows us to use Python features like decorators and define functions directly in that workflow. I'll show you later on something called closures and scope, which is very specific for that DSL and is not defined natively in Argo, but I believe it might come in handy for some of you. Other than that, workflow generation and templating. If you've ever tried to template workflows, you probably use something like Jinja. And if you did, you know what a pain it is. So using this DSL, you can template and generate tasks, for example, natively with Python. And lastly, testing. You can basically define all your functions, test them ahead before submitting the workflow, and therefore avoiding clumsy debugging in the cluster of typos in your Python code. Now, I say we. Who are we? We're basically a growing community of Argo workflow users, and mostly Pythonists. I'm part of Project Toth, which is a team at RedHat that specializes in usage of artificial intelligence and analysis of software stacks. We created Argo Python client, which has been created to ease our workflows, so to speak, in Python, and to use Python clients natively. And we are also Argo enthusiasts, and plenty of people come to us and ask us about Argo, and most of these people work in Python, like QEs, for example, who wants to use Argo for automation of their tests, etc. And these tests are written in Python for scripting purposes. So we're simply whomever wants to use Argo workflows with or without Python. So what can we do with these? Let me show you a quick demo. In the repository, the link will be in on the last slide. You'll see these examples. So feel free to take a look at this. And I'm just briefly going to show you some of these. So here you can see the Hello World example and the definition that I showed you before. So the main idea behind this workflow definition is that workflow is sort of a meta class that you inherit from. Whatever you specify as an attribute to this workflow will become part of the spec of the workflow if it's a valid attribute according to the specification. And then we can basically specify a template as you're used to, which would match one of these templates specified in the spec. And using this decorator, we just return a model that is valid for a template. In that case, that would be a container. And you can see that it projects directly into the specification right here. So what's below this is just for testing purposes, because we also use these for tests. So let's skip this hello world example part and go to something more interesting, which would be the DAG diamond. Again, example from Argo Workflows. There are 4 tasks, A, B, C, D, and they have dependencies, and I don't think they have inputs except for this last template. So again, you denote each function with a task decorator. You can provide the parameters in a quite intuitive way. If you wanted to provide more, you just use another parameter decorator, and you can provide also dependencies, etc., etc., etc. There is something called compilation, which might be interesting to you. And there is a hidden compile parameter, which is by default set to true. If you set it to false, you can basically see all of these objects not compiled. So don't be scared by this parameter compile. It may come in useful if you want to dig deeper into these workflows, but in most cases, you won't use it. So the compilation part is what basically turns the Python objects into the relevant specification. Now, what might be interesting is the auto completion of basically any object that is here. So for example, if you have artifact, as this is generated from the Swagger specification, you can see all of the attributes that you can provide to the artifact. Sometimes, and I think this is the only exception, there is an underscore because from is a reserved keyword in Python. But other than this exception, there shouldn't be any, and it should really fit the specification. What might be useful as well are 2 things. So when it comes to generating these block literals, sometimes you see really clumsy blocks of strings in Python in YAML. What you can see here is that the DSL also generates block literals, so you can see it really in the same fashion as it would be defined in the original manifest. And as I mentioned before, there are 2 specialties, and that would be closures and scopes. And let me explain very briefly what that is. So let's say we have this YAML specification where we have a template which contains Python code, these 3 lines. So just an import and print for the simplicity of the example. So we can either do it, let's say, the old-fashioned way, just use the source as a raw string and provide it to the v1 alpha1 script template and return that template. That would be the ugly way. I don't like it because we work with Python and I want to work more natively. So what closure allows you to do is you would define the Python function in a very normal way, just like any other function, and then you wrap that function in a closure. The only thing you have to provide is an image which should execute the Python code. In the future, we might potentially eliminate even this thing because we in our team analyze source code and dependencies of functions directly, so we might actually do this dynamically and provide a relevant image, but right now the image has to be provided. And as you can see, the resulting definition is really the same. What scope is, and I don't have example for it right now because it's pretty new, is again a decorator which allows you oh, is it a decorator? I don't know if it's a decorator, maybe not. But scopes allow you to bind these closures together. So you might have multiple closures, and if you bind them in a scope, which you would denote something like scope blah blah blah, then these closures share the variables and the objects defined in them, which again might be handy so that you don't need to write functions that have multiple billion gazillion lines, but you can simply have multiple functions and bind them in the same scope. So that would be for the demo. And I also have some common questions that I'm asked very often, and that would be, how does it compare to Kubeflow DSL? If you're familiar with Kubeflow, you know that there is DSL, more precisely Kubeflow pipelines DSL. So this Kubeflow DSL is a very high level abstraction specific for Kubeflow pipelines, and it is really very far from the original Argo Workflows declaration. It doesn't allow you to specify these Argo workflows natively. It doesn't have all the capabilities, whereas this DSL is really quite low level, and it has all the models that you need to create full-fledged Argo workflows. So you can say that Kubeflow pipelines DSL can be in the future based upon Argo Python DSL. And how can you contribute? So take a look at Argo, take a look at workflows and pipelines, join the community on Slack. And of course, there is the GitHub repo for Argo Python DSL, which is currently under my user account, but will be soon migrated under Argo Project Labs. So take a look at this organization, and you can of course contribute to another projects here as well. Do you have any questions?
I had one question for the community, Mark. This DSL is, as you said, is focused on every feature of Argo workflows. Question is, do anybody see a need to have another abstraction on top specific to any data processing or specific to machine learning instead of Argo workflows directly? Like, are people looking for more abstractions, or this is what people need?
Mm-hmm. So people might be looking for more abstractions, and we've been sort of preparing for people coming up with their own plugins. Currently, it's not that easy to get the grasp of it, but it should be possible in the future to come up with your own sort of modules, let's say, and to just plug them in and use them. Basically, each of these modules would just have to be very similar to a Swagger defined module, and once you plug that in, the parser will take care of everything else.
Okay.
So I don't think that we will ourselves implement anything else, although there has been an initiative to have a functional API for it, so that we can work with it not just on an object oriented level, but also on a functional level. And that would make things like generating tasks quite easy and much easier than it is now. But as far as abstractions and higher level decorators are concerned, we're not planning anything right now.
Okay. There's a question on the chat. What is the roadmap of Python DSL? When is the initial stable release?
Well, that depends on the definition of stable, but 0.10 should be released quite soon, and by soon I mean in a matter of weeks, and hopefully we'll attract more contributors once it is migrated under Argo Project Labs. So then we'll see what really community wants. As far as the roadmap is concerned, my current, let's say, my biggest concern right now is to keep up with Argo releases and to provide support for each release. Currently, the stable, so to speak, is 2.4.0. 2.5.0 will be supported in 1.0, and for Argo 2.6.0 there are still some complications.
Okay. Yeah, Argo 2.6 was a big release. Hopefully, Alex, you can say, like, after this, there shouldn't be much changes, at least in API, etc. Right? So the Python DSL shouldn't face issues.
That's correct. It was 2.5 that was the big release, and the big change was that we introduced the Argo server along with all the various APIs that come with. Now those APIs are basically stable now, so you shouldn't expect them to change in any kind of breaking fashion from now on. It's just that you need to support those APIs if you want a full and complete feature set. And hopefully we've also got the Swagger specifications up into a standard that it's relatively easy to produce clients in different languages. So we also have a Java client as well.
Mm-hmm.
Anything else, Alex, or should we move to the?
No, let's move on. Marek, thank you very much for taking that. I've now managed to sort my sound out, or rather, it seemed to just sort itself out. So I guess that's the same outcome. Next, we've got Vaibhav.
Thank you for having me.
Vaibhav,
Sure.
You guys are.
Mark, can you post the slides on Argo Slack? Yeah, for people, those who couldn't join. Yes.
Yeah, I will.
Okay, Vaibhav, take it away.
Yeah, sure. Thanks, Alex. Can you guys see my screen?
Yes.
Perfect. Hello, everyone. My name is Vaibhav. I'm a software engineer at Blackrock, and I'm maintainer of Argo Events. So today, I'm going to basically discuss what Argo Events is. I assume some of you already are using Argo Events in some shape or form, but for the folks on the call who are not familiar with Argo Events, I just want to kind of give a brief overview what the project is about and how it integrates with workflows and what are different types of use cases you can use this framework for, and what are the use cases that we use it at Blackrock. So to start with, what is Argo Events? So it reads that Argo Events is Kubernetes native event-driven workflow automation framework. So there are a lot of things that are going on here, right? First is event-driven. What that means is this framework is designed in such a fashion that it is a gluing mechanism between the Argo workflows and the events that are basically basically originate outside of the Kubernetes cluster where your workflows are running from. For example, let's say you have events on GitHub, GitLab, AWS, SQS, queues, SNS messages, and all that. But those are kind of like decoupled from your Argo workflows, and most of the time you want to basically stitch those events to the workflows in order to kind of like set up some pipelines to do some automation work and that kind of stuff, right? So Argo Events is that framework which basically stitch events with workflows, and it helps you basically automate a lot of pipelines. So the very high level architecture of Argo Events, it has two main components, a gateway and sensor. So gateway is pretty much, it listens to events from all these different sorts of external event sources such as S3, GitHub, SQS, SNS, GCP, PubSub, Azure, blob storage and all that, right? And then you have sensor. Sensor is the component which actually triggers the workflows for you. So by using both gateway and sensor, you basically stitch events with workflows. Now, before like going into the demo, I'm just going to kind of explain why you may need events, because I assume that most of you are doing some sort of like data science or machine learning, like you're writing machine learning models or you're dealing with that sort of work and you're using Argo workflows for that. And that's great, right? Because Argo workflows are kind of like, they are meant to do that sort of work where you need some sort of like a DAG that represents your machine learning model or some data science stuff or some image processing pipeline or ETL pipelines, right? But if you look at a real world use case or real world scenario, most of the time you want to actually automate that machine learning model or that ETL pipeline upon some event. For example, let's say there is a file drop on S3 and you want to trigger your ETL pipeline, or there is a push event on GitHub and you want to run your CI pipeline. So that's where Argo Events comes into picture, and it helps you basically automate your pipelines easily. So in this demo, what I'm going to basically show is very simple image processing pipeline that you can set up using Argo workflows and Argo events. So what we're going to achieve here is you have on the right-hand side a very clean Argo logo, and we are basically going to write a simple Python script using Jupyter Notebook, and we are going to add some noise to that image. And then we are going to basically fine-tune that Python model so that the clean image and the image with noise has more than 80% of similarity. So let me first show you what those two Python scripts look like. So these are a simple script that basically uses Gaussian filter to apply the smoothing and then add some noise and then store that output image onto the S3 bucket. And then I have a different script over here. What that does, it reads that output file from S3 bucket and it compares with the original file, and then it basically looks for the similarity measurement. And depending upon whether the similarity was more than 80% or less than 80%, it dispatches a message on NATS queue. So I'm just using NATS as a mechanism to kind of like get the notification of what has happened in the workflow. You can basically, let's say I could have put a Slack notification over here or email or something like this, some sort of like messaging mechanism that will let us know what has basically happened with the this particular script that runs in a workflow. So if you look at the first script, it basically applies that noise and it takes some parameter, right? So what we're going to do is we are going to use these tools to basically achieve that pipeline. Again, Jupyter Notebook, Papermill is for parameterizing notebooks, Argo Events, Workflows, pretty obvious, and Minio as our kind of like a storage for storing the output images and output notebook files. So this is the flow. So let's consider there is a researcher who is trying to basically use this noise model to generate images that have some similarity with the original one. And that researcher wants to basically pass some parameters for the Gaussian filter and for the noise, right? The way we are going to achieve this is we are going to basically expose that Jupyter notebook for that pretty much introduces noise using Argo Events webhook gateway. So what that does, it pretty much exposes that notebook through the HTTP server. So that researcher can basically make a curl request or HTTP post request and pass the parameters and fine tune that model so that the original image and with the noise has more than 80% similarity. Once the researcher sends a particular post request and this Jupyter processing, image processing Jupyter notebook executes in a workflow, the output of that workflow is going to get stored on S3, which is going to basically trigger another workflow, and that workflow is going to run a Python model that does image similarity check, and it's going to publish result onto Nets. So let's look at this in action. So I already have this setup ready running in my local Minishift cluster. I have webhook gateway sensor, webhook gateway and webhook sensor running. I have Minio gateway and Minio sensor. So the gateway and sensor are pretty much of a particular type. For example, webhook gateway, it listens to HTTP requests. Minio gateway, it listens to events on Minio S3 storage. So what I'm going to do is I'm going to first send a curl request to webhook gateway, and I'm going to pass these parameters. So filter A, filter B are the size of Gaussian filter matrix, and then how much amount of noise we want to introduce. So treating me as a researcher, these will be my parameters to fine tune the model. So once I make a post request, the sensor is going to trigger the Argo workflow. This workflow is going to generate that image that has some noise in it. And it's going to publish that output onto S3 bucket. So it is running the notebook, and it is actually leveraging Papermill in order to parameterize those filter values and input values that has been passed by me. So let's go to the noisy images. Now you see there is a blur Argo logo available over here. So let me show you. So this is what the logo looks like with the image. And as soon as the image was dropped into this bucket, the Minio gateway triggered another workflow to match this image with the original one. And it did match. And let's check the similarity measurement on the nets. So it says failure because similarity was only 0.79. We are expecting something over 0.8. Now let me actually go to the gateway and definition sensor so that you guys will get more kind of like an insight into how it works. So whatever the events that I pass to the webhook gateway are passed to webhook sensor. And over here, I'm basically using Papermill in order to execute the Jupyter notebook that introduces the noise, but I'm going to pass these parameters on the fly to my container. So this is how Argo events let you basically extract different values from event and then inject them into your workflow definition so that you can on the fly change the parameters to your whatever command that you're trying to run or any of the field within that workflow definition. So I can change whatever I wish using the parameters on the fly, and I can run that. So this is how the webhook sensor basically takes the input request and changes the values of the filters and the noise amount. For the Minio gateway, what it's trying to do is pretty much going to run the image matching notebook, which only takes 2 arguments. So there is really no need to parameterize anything over here, but I did nonetheless. So let's go back. Let's check. Now we need more than 0.8% to make sure that our model is something that we can put in production. So I'm going to send another curl request with different parameters this time, so that it will have that more than 80% of the kind of like similarity with original and the one with the noise. So you see, it triggered another workflow, it completed. It also basically overrode the image with the new one, and that triggered another matching workflow, and it ran successfully. And if we go back to the NATS queue, it's going to send a success message with more than 80% of similarity. So you see, now we get the success message with 0.84 similarity. So now, as a researcher, I can say that, oh, these parameters are perfect for my model, and my model is something that I can deploy into production. So using Argo Events, you can set up pipelines like this. Now, this was a very simple, straightforward example. You can essentially take concepts from this example and apply to actual machine learning models, where you're trying to basically fine-tune different sorts of models and scripts to get the optimal result. But let's take a step ahead and kind of like see how we can actually take this model that we just fine-tuned and deploy it into production. What we are going to do for that is we are going to drop the output notebook file, which has the correct filter values and the amount of noise. And then we are going to put it on S3 bucket. And that's going to basically trigger a event. And there is a Minio gateway, which is kind of like configured to deploy that Jupyter notebook as Kubernetes deployment. And that Kubernetes deployment is going to expose that Jupyter notebook through HTTP server. So what this whole entire workflow is doing, the pipeline is doing, is basically it is taking that Jupyter notebook, a simple Python script, and it is converting that into an HTTP server, so that any other team member or any other employee in the same firm can basically just make a curl request to that HTTP server and get the output from that Python model. So let me go to the Minio browser. So this is the kind of like a Minio UI. So I have the output Python file or Python Jupyter notebook file over here. I'm just going to download this, and I'm going to actually push it into a bucket called as production. So what that means is when I push any notebook file into this production bucket, there is a gateway that is configured to listen to this bucket. And as soon as something gets dropped into this bucket, it's going to make that Jupyter notebook available as the available through HTTP server through Kubernetes deployment. So I'm going to upload this noisy out. I already had this one. So as soon as I uploaded that, you can see there is now a new deployment, noisy out.ipynb, which is Jupyter notebook. And it's deployed as a deployment, and it's exposed through a simple Gin HTTP server. And if I go over back to the terminal, and let's just consider I'm a different user now, and I want to use this particular model to get the output result. I created another user bucket. So what I'm going to do now is I'm just going to basically query the model that's running as HTTP server. And what this particular curl request is as a user, I'm saying, hey, I'm making this request, store the output of the model into the bucket called user1. So as soon as I need to port forward it, give me 1 sec. All right, so as soon as I make a request, you will see that it's going to run that model again, but now this time it's going to store the output over, under the user1 bucket. So let's go back over here. There you go. Stop with those. See, it's the same a kind of like the image that matches more than 80%. So we kind of like successfully productionalized our Python model. You can basically treat this Python model as any other machine learning model. We are trying to productionize your Jupyter notebook from a research mode into a production mode. So that's for the demo. It was super easy to set everything through Argo Events. These are the links. So there is already this demo available under my GitHub account. If you are not familiar with Argo Events, I would encourage to go to the GitHub repo, check the code out. And if you want to join the Slack channel, this is the link. And we at Blackrock are hiring for our data science and compute platform. So if you're interested, send me your resume at my email ID or ping me on Slack to know more about the opportunities. Thank you very much. Any questions?
Yes. Can you hear me?
Yes, I can.
Hi, this is Tomasz from SAP Concur. So we use both products, Argo Workflows and Argo Events. I have to say, huge thanks to the entire Argo community. It's been, we're getting awesome support, and the product itself is just the soul of a Kubernetes, I can say. It's really nice. Question I have to Vaibhav. So we currently submit one big Argo workflow file into the Argo Workflows engine, and we would like to break it into smaller pieces. So break it into workflow templates. Does Sensor can submit workflow templates, and in a certain order? You know, you need to first the way the workflow templates work. You need to follow certain order before you submit the actual workflow. Is this doable with Sensor?
So actually, I would defer this question to Alex. Alex, is workflow template something you can submit on its own through, like, for example, just a kubectl apply and to the workflow or the Argo submit workflow template?
Depends what your use case is. So in 2.7, I think we're introducing a new command, Argo submit -- resource, and that allows you to basically submit a workflow template as a workflow, so you can treat them as effectively a library of reusable templates. And the same goes for cron workflows. In fact, you can submit a cron workflow in the same manner if you want that to run now.
Yeah, then I think once I think the Sensor can leverage that functionality, but as of now, I think what you can do is you can split your workflow into different triggers, and you can either wait, like basically sequentially go through those triggers and run them, or you can basically set up a resource gateway that watches certain type of Kubernetes resources being created in the cluster and then take some action on that. I'm not sure about the second approach, but if the Argo submit with the -FN resource is introduced in 2.7, you can definitely leverage them.
Okay, perfect. I would either wait for 2.7 or maybe I'll discuss this offline with you, Vaibhav, about the first option. Thank you so much.
Any more questions? Ooh, science. Okay, I am going to share my screen now. If I can find the share button, here it is. So can you see this presentation?
Yes.
Brilliant. We have to check these things, don't we? So around 6 to 8 weeks ago, I can't remember the exact date, we sent out a Google Forms survey, and we got back the responses a couple of weeks ago, and we've been collating them to see if we can draw out any kind of insights into this. I'm going to go through this relatively rapidly. So if you particularly want to ask about a particular topic, then jump into it. The reason I'm going to go through it relatively rapidly is I'm probably going to just talk briefly, why did we ask this question? What did we learn? And then kind of move on from there. The first question we asked about was what kind of roles were people involved in? We wanted to kind of understand partly how strong the ML influence is in there, and it's quite interesting to see a kind of interesting roles such as data engineering and data engineer consultant come out of this. This is a word cloud, which are quite 2015, I guess, but the larger the item is, the more responses that were related to that. The second question we asked was what was the use cases, and we got just a lot around machine learning and data pipelines. I suspect this is probably nothing new to anybody here. We also got 1 or 2 responses around doing continuous delivery, which is quite interesting. We wanted to ask about features. The reason we want to ask about this is we want to know how important these features are to anybody. And it's pretty no surprise here that kind of some of the newer features, such as node offload status, were not heavily used, whereas things like artifacts and parameters are used almost completely across the board. We asked about executors. We're interested to see how that would spread out, and obviously Docker dominated the executors that people used here as well, with the kubelet executor actually coming in last place. We actually use the process namespace executor ourselves. Again, artifact storage. I feel like probably no surprises here. Again, S3 really dominating artifact storage. We want to know about the ecosystem. We want to know about what other products and tools we sit alongside. I was really pleased to see Argo CD in there, as well as Argo Events as well. We were also interested by Airflow, so we're going to do a bit more looking into things like Airflow and obviously Tecton at some point in the near future. Again, what alternatives have you considered? What we didn't ask is why did you switch from these ones? So it'd be really interesting for anybody who has chosen these tools and switched to Argo workflows to kind of know a bit about why you did that. And again, you can see there's a note here for drone CI in the list and Tecton. We asked about versions. We're probably going to ask about a bit more about this in the future. One of the hot topics within the core team is whether or not we should be releasing quite so frequently as we are. What's the right release cadence? So this is quite interesting. We've also asked this same question recently, and it looks like most of the people who are on 2.5 are now on 2.6, but actually most of the people running 2.4 are still running 2.4. Be interested to know from people why they hold back on that. The final question we asked around was what features could we build that will make your experience better? I'm interested again hear from anybody who wants to comment on these. I believe we've actually delivered a number of the features of these 39 features here on the lists, but I just wanted to share this out with you as well in case you were interested. Okay, that was quick. Does anyone have any questions they want to ask about the survey? Okay, that's fine. Okay, what I'll do is I will add a link to these survey results to the Google document, and you can have a look. And they can also be found in the community folder in a kind of different format, in a PDF format, if you're looking for them. Okay, well, thank you all very much for joining us today. I hope you guys have enjoyed the demo. Do drop onto the Slack and say hi to everybody. Don't forget to tweet about things you enjoy. Don't forget to keep helping out. We love when people get stuck in and commit code contributions. And I hope you all stay safe and well. Bye-bye.
Thanks, bye.
Bye guys, thanks.